Today we're going to go over section 9.6. For those of you who are kind of on top of things, you realize that we skipped section 9.5. I never do that one. It has everything to do with graphing calculators, so we're not really going to mess with that. Especially this year, we're not going to mess with that. So section 9.6 is called solving quadratic equations by factoring. I figured since I haven't been on a video in a while, that means I haven't got to mess with Gabby's dogs, Piper and Bailey, so I figured if I can get them excited. Piper, Bailey! You have to let me know what happened there, Gabby. Alright, so we're going to start out by doing something kind of that doesn't seem like it fits in anywhere, but it actually ends up being a huge deal. We have the zero product property. I have the first half of it here, the if statement. I'm going to fill in the then statement with you and explain it a little bit. It says if AB equals 0, so in other words, if A times B equals 0, then what? Now, if you were sitting back in the traditional classroom, I would do like, hey, think about it, partner up with somebody, and see if you can come up with what it means. That's a little bit hard to do. But what it means is if A times B equals 0, then we know A equals 0 or B equals 0. One of those, I guess both of those, but one of those has to be true. There's no way to multiply two things and have a product of 0 if one of them isn't 0. And again, I know that might seem random, but we're going to use this zero product property in order, went the wrong way, in order to solve these quadratic equations, okay? So if you multiply two things together and the product is 0, that means one of the two things has to be 0. So let's see how we're going to use that zero product property. All right, first example, we have x squared minus 7x plus 10 equals 0. Now, for some of you, you're not going to think this is a big deal. Others of you will probably have to keep in check your gag reflex. But we're getting ready to factor again. All right, so we're going to factor this trinomial. It's a trinomial with a leading coefficient equal to 1. That's a plus sign, so we know they're both positive. I'm sorry, they're both the same sign. And because that's minus, we know they're both minus. So right from the get-go, we know it's going to be x minus and x minus. Now, since this is an equation, it's equal to 0. So we need two numbers whose sum is 7 and whose product is 10. Well, that's 5 and 2. So we have x minus 2 and x minus 5. Okay, now we factored, but we still haven't solved this equation. Well, we have the zero product property. I'm multiplying two things here. This binomial times this binomial. In other words, A times B, if you want to think back to that original statement. When I multiply these two, the product is 0. So that means this either has to represent 0 or this has to represent 0. So we're going to set each factor equal to 0. X minus 2 equals 0. X minus 5 equals 0. Well, solve that simple equation. So you add 2 to both sides, you get x equals 2. Add 5 to both sides, you get x equals 5. And there we go. We have our two solutions. So back in the beginning of the year, when we were on chapter 2, we would solve an equation and we would get one answer, assuming we didn't get all real numbers or no solution, but most of the time you get one answer. Whew, I got a sneeze coming on here. So now when we solve a quadratic, we can get two answers. We can also get one, we can also get none, but for today, we're going to get 2 answers every time. Now, x equals 2 is a solution, and x equals 5 is a solution. So let's see what we got here on the next slide. All right, I'm going to show that both of those are solutions. We're going to do that by substituting the answer back in. So if I have 2 squared minus 7 times 2 plus 10, and that's equal to 0. I get 4 minus 14 plus 10 equals 0. I don't know why I put 10 there, I meant to put 0. 4 minus 14 is negative 10. Negative 10 and positive 10 are 0. I get 0 equals 0. Should be able to do the same thing with the 5. So take 5 and square it. Minus 7 times 5 plus 10, and that should equal 0. So now I have 25 minus 35 plus 10. That's equal to 0. 25 minus 35 is negative 10. Add 10. 0 equals 0. So I don't know if you remember back to when we started talking about the zeros of a quadratic function. And what we did is we had a graph. And I said, hey guys, these are the zeros. In other words, they're the x-intercepts. I also said at that time, I was like, they're actually called a third thing. They're called the solutions. All right? Notice, when I solved, I got 2 and 5. When I substituted 2 and 5 in, I got the value of the equation to be 0. So the solutions and the zeros are the same things. It's also the x-intercepts. So if we were to look at a graph of this quadratic function, it would have x-intercepts at 2 and 5. And if you don't believe me, there's the graph. There's the x-intercept at 2, and there's the x-intercept at 5. Okay. We have x squared, having a tough time here. X squared plus x minus 12 equals 0. So we're going to factor again. I know that that's different signs, so I'm going to have x plus something and x minus something, and that's going to be equal to 0. I need two numbers whose difference is only 1, that's a ninja 1 there, and whose product is 12. Well, that's going to be plus 4 and minus 3. Again, we're going to use that zero product property and say, well, we need to find the number that makes this 0, and we need to find the number that makes this 0, because one of them or both of them have to be 0. Well, if that's 0, I can set that whole quantity equal to 0 and solve, and I get x is negative 4. I can set this quantity equal to 0 and solve, and I get x is 3. So there are your solutions. One is negative 4, and one is 3. Okay, let's show that they're the solutions. So I'll substitute in negative 4. So it's negative 4 squared plus a negative 4 minus 12 equals 0. Square negative 4, you get positive 16. Plus a negative 4 is just minus 4 minus 12. 16 minus 4 is 12. 12 minus 12 is 0. So that one works out. Plug in 3. You get 3 squared plus 3 minus 12 is 0. That's 9 plus 3 minus 12 is 0. 9 plus 3 is 12. Minus 12 is 0. So we just proved that those are the solutions. Just like with linear equations, or any equation for that matter, you can substitute the solution back in and you should get a true statement. Again, we call these the solutions when we're solving the equation. All right? When we're talking about the value of the equation, the y value, it's equal to 0. We just showed when you substitute it in, you get 0. The next slide is going to show you that when you graph, those same two numbers, -4 and 3, will also be the x-intercepts. There's -4, there's 3. Hopefully that shows up on the film. I don't know if that laser does or not. X squared plus 5x equals 0. So you might look at this one at first and be a little bit confused, because technically you might think, well, it's this. Now how do I solve that? If you're thinking that way, you're forgetting about that suggested list that I gave you. The very, very first thing you should always look to factor out is the greatest common factor. The greatest common factor here is x. Factor that out, and I get x times the quantity of x plus 5. All that's equal to 0. So take this first factor, set it equal to 0. There's not any work to do there. Take this second factor, set it equal to 0, and when you solve, you get x is -5. So there's your two solutions. One of them is 0, one of them is -5. I'm going to show you that they're the solutions. So I'm going to plug in -5 and square it to add that to +5 times -5. Square -5, you get positive 25. Positive 5 times -5 is -25. 25 minus 25 is 0. So we get 0 equals 0. So that checks out. Take 0 and square it. Plus 5 times 0. 0 squared is 0. 5 times 0 is 0. 0 plus 0 is 0. So there's both solutions. One of them is 0, one of them is -5. And just like the previous two examples, if I show you the graph, those two numbers will also be the x-intercepts. There's -5, 0, and then there's the 0 of 0. Okay. This one has a leading coefficient equal to -1. My advice is to factor that out the very first thing. So factor out that -1, and I'll be left with x squared minus 3x minus 4 equals 0. And now you can factor this. We have different signs. So one of them is x plus, one of them is x minus. So that's going to be +1 and -4. Now we have three factors. And technically, I guess we need to set all three of them equal to 0. But it looks really weird when you set the first one. It says -1 equals 0. Well, that's garbage. You can just throw that away. And then set the other two equal to 0. So I get x plus 1 equals 0. That means x is -1. I know there's a big bright spot down there sometimes. Hopefully you can see that. That just says x equals -1. And then x minus 4 equals 0. X equals 4. So the two solutions to this quadratic equation are -1 and 4. So I'm going to show that they are. So the negative of -1 squared plus 3 times -1 plus 4 is 0. Square -1, you get 1. Drop that negative, now it's -1. Positive 3 and -1 are -3. Add 4, we're claiming that's 0. -1 and -3 are -4. Add 4, you get 0 equals 0. Kind of of looks like a smiley face. You can tell I need to go outside more. All right, plug in 4. So we get negative 4 squared plus 3 times 4 plus 4 equals 0. Square 4, you get 16. Drop the negative. 3 times 4 is 12, plus 4 is 0. Negative 16 plus 12 is negative 4. Negative 4 and 4 are 0. So I get 0 equals 0. Right. So once again, I have proven that both of those are the solutions. I plugged it back in, I got a true statement. Okay, that's why they're solutions. When I plug them back in, I get 0. That's why they're also called the zeros of the function. And to repeat myself for the 100th time here, these are also going to be the x-intercepts. There's the x-intercept of negative 1, and there's the x-intercept of 4. Probably what you were hoping wouldn't happen is about to happen. We have a leading coefficient not equal to 1, and on top of that, it's not equal to 0. So let's fix that not equal to 0 thing first. If it has to be equal to 0 and it's not, make it happen. So just go ahead and subtract 6 from both sides. And now we have 6x squared minus 5x minus 4 equals 0. Okay. Which method? I'm just going to do guess and check here. So we don't know anything though. So maybe this wasn't a good candidate for guess and check. This is going to be 6 and 1 or 3 and 2. And this is going to be 4 and 1 or 2 and 2. It's different signs. I can't put the signs in yet. I always like to start with the 3 and the 2 versus the something and 1. So we'll go 3x and 2x. Okay, 4 and 1. I can't put 4 with 2 because that would create a greatest common factor that doesn't exist. But I can put 4 and 1. And I think I got it right the very first time here. Multiply the inside, that's 8x. Multiply the outside, that's 3x. The different signs, we need the bigger number to be negative, and this number will be positive. So that means the negative needs to go there, and the positive needs to go there. So we have 3x minus 4 and 2x plus 1. Those are our two quantities. So set them equal to 0 and solve. So that'll give me 3x equals 4, divide by 3, and x is 4/3. Again, I hope you can see that. I know there's a, I don't know if that helps or hurts. I know there's a bright spot there sometimes. And then 2x plus 1 equals 0. Well, transpose that over. I get 2x equals negative 1. Divide both sides by 2. And x is negative 1/2. So the solution to this quadratic, the two solutions I should say, are 4/3 and negative 1/2. Since I'm a glutton for punishment, let's substitute these in and prove that they're the solutions. So I have 6 times the quantity of negative 1/2 squared minus 5 times negative 1/2 plus 2 is 6. So square 1/2 and I get a 4th. So 6 times a 4th. A negative and a negative make a positive. And that would be, put that over 1 and multiply, that would be 5/2 plus 2 equals 6. Put that over 1 and multiply, that would be 6/4 plus 5/2. Ooh, I don't know what happened there. Try that again. Plus 5/2 plus 2 equals 6. Now, 6/4 reduced to 3 halves plus 5 halves plus 2 equals 6. We'll pick this up over here. 3 halves and 5 halves, that's 8 halves, plus 2 equals 6. 4 plus 2 equals 6. 6 equals 6. So -1/2 worked. I plugged it in and I got a true statement. Now, don't get confused. Don't think, well, there's not the zeros. Subtract 6 from both sides and you get 0 equals 0. It still works out that way. Let's try this same thing, but let's plug in 4/3 this time. Piper Bailey. All right, so plug in 4/3. Square 4/3, and we're going to get 16/9 minus 20/3 plus 2 equals 6. Put that over 1. Now, when you're multiplying, you can reduce any numerator with any denominator. So that goes in twice, that goes in 3 times. That'll give me 32/3 minus 20 halves plus 2 equals 6. In order to combine these, we need a common denominator.
Hello?
I sure hope I'm doing this right.
Not much. What do you got?
So we need a common denominator. That'll be 64/6 minus 66 plus 2 equals 6. I've messed up. This is 20/3. Somehow turn that into 20 halves. Okay. Yeah, my 3 became a 2 right here. So let's try that again. This is going to be even easier now. So 32/3 minus 20/3, that's going to be 12/3 plus 2 equals 6. Bring that up. 12/3 is 4. 4 plus 2 equals 6. 6 equals 6. All right. Sorry for the glitch there, but hopefully you didn't get too lost. It was an easy fix. So again, it was a true statement. Now, the graph of these converted them to decimals. So remember, 4/3, 3 goes into 4 one time with a remainder of 1 out of 3. So it's going to be 1.333333 repeating. So we get -0.5, which is -1/2. And then the 1.3 repeating, which is 4/3. Okay. So the quick version of this section, factor, set your factors equal to 0, solve for x, and that gives you the solutions. Okay. When you do the homework, you do not have to plug it back in and show me that it equals 0. Okay. I just wanted to prove to you that it did. If you were taking a test in a real situation, you'd want to do that because you'd want to know if you got the answer right. The only thing you have to do is solve. If you have a calculator and you want to throw it in the calculator and check real quick, you can. Okay, just solve and set them equal to 0. Just factor, set them equal to 0, and then solve. That's all you have to do. Okay, so in other words, do this slide when I had x equaled 4/3 and x equals -1/2. You're done. You don't have to do the prove that it is and all that stuff. Speaking of homework, enjoy the rest of your day. All right, I'll post a paper and pencil type homework assignment on Thursday over this material. So hopefully you took notes. Hopefully it made sense. If you have any questions, I'll be in office hours or you can send me an email. Miss you guys. Hope everything's going well. I think it's going to be a rainy week, but when it's not raining, try to get outside and get some fresh air. I'll see you guys later.